experiment is running a C++ program, and what's the catch here? What have they given in the question? They have given that either the program will run in first go, it will be successful, or it may not run in the first run, but once you run it second time, it runs successfully. Or it may not run in the first time, second time, it may run successfully in the third time, and so on. So in this case, if you ask me what is the sample space, the sample space looks something like this. And you stop. The moment the program runs, you have achieved success. You have written the code correctly, so you don't have to progress further. So, your sample space will be that you achieve success in the very first time, or you go ahead and you have a failure in the first time, followed by success in the second time, or failure in first 2 times, then success, and so on. So this entirely becomes your sample space. Okay. Now, let's define the next thing, which is known as an event. Now, please understand. A sample space is all possible outcomes. An event is only few of those possible outcomes depending on what you desire. For example, if I tell you that, let's go back to the basic thing. This is my sample space, that it can be male or female. My event can be that the gender of child is female. So the possible result of this event would be, similarly, my event could be that the gender of child is male. So in that case, the possible outcome is this. So what is an event? An event is a subset of the set of the experiment. Okay, or sample space, to be precise. So event is a subset of the sample space. Sample space is everything. Event is smaller than that. So for example, here, my event can be that the number of gas stations, gas pumps, not station, the number of gas pumps working in each gas station are same. So I'm asking that out of the total sample space that you just built, which are those cases where the gas pumps working in the 2 gas stations are the same? So these scenarios, this diagonal. Here, the number of working gas stations are the same, right? So basically, all this becomes my sample space. This becomes my event from my sample space. Let's take one more example. So it says that, okay, let's read it out first. An event is any collection of outcomes contained in sample space S. So out of the sample space S, I'm talking about a smaller collection of outcomes. An event is simple if it consists of exactly one outcome, and compound if it consists of more than one outcome. That also I'll show you. So take this example. There are 3 vehicles. Each of the vehicle can either turn right or left. Now this says there are, so if each of the vehicle can turn right or left, if you ask me what will be the sample space, it will have 8 possible outcomes. All 3 vehicles turned left. First one turned right and rest 2 turned left. First left, then right, then left. So first 2 left, then right, and so on. These are all the possible outcomes that I may have. Right? So, you know, for each of the car, you have to think that the first car can turn left or right, left or right, left or right, left or right. The second car, when the first car is turning left, can turn left, or when it is turning right, can still turn left. The second car, when the first car is turning left, can turn right, or when it is turning right, then also it can turn right. Right? The third car can turn left when the first 2 are turning left, or can turn left always. Right? Similarly, the second car can turn left, left, right, right, but the third car can always turn right. So you have got all your possible 8 outcomes out of this. None of them is matching. They're unique possible 8 outcomes. Now, once you have got all of these outcomes that I've written here, I'm asking what are different events. So the first event is all vehicles took left. Only one possibility, right? When all the vehicles took left, which is this LLN. So because there is only one outcome coming here, it is a simple event. Now take this. This is my second event. So my second event is at most one vehicle turns right, which means 2 things. At most one means either no vehicle turned right, or one vehicle turned right. These are the 2 possible things. Either none turned right or one turned right. So I've written all such possible outcomes. So one of them is turning right or none is turning right. This becomes a compound event because I have more than one outcome in my event. All 3 vehicles took the same direction. So left, left, right, or right, right, right. Again, a compound event. I want you to try different scenarios. So take an event where I'm saying at least one vehicle turned right. So you have to show me that there will be 7 such outcomes within the event. Because if at least one vehicle turned right, only this will not be included. Rest, everything will be included. Okay, take another event. Exactly 2 vehicles turned right. So you have to show me the probability of this will be, there will be 3 such events. So exactly 2 vehicles turned right means this one, and this one. Right. So you can take various events and try it. Now, again, remember the question that I just did, which was on programming. Let's see what are the different events possible. So my sample space was this. Either you get success initially, or you fail first time and then get success, or you fail the first 2 times and get success, and so on. Now, my event is at most 3 programs examined. So you can't go beyond running the program 3 times. So you ran first time and you got success, or you ran 1 time, you got failed, and then the second time you got success, or you ran the first 2 times and got failed, and the third time you got success. You won't go beyond this because it says at most 3 programs. Now, next event can be even number of programs examined. So which means You cannot have a situation where you get success in the first time. You get failed the first time and success the next time. Even number of occurrences of running the program. Or you get failed 3 times and then success. Or you get failed this many times and then success, and so on. But you have to make sure that it is even number.